Hello and welcome to this new episode of microservices and containers. In last episode, we talked about containers, how it works, and how it's different from virtual machines. In this episode, we continue talking about container, how to install Docker, and why it's useful for developers. There are two main points we want to talk about. For developers, point one is they can use Docker to build their application using whatever language of choice and whatever version. And the second thing is the ability to package their application in order to be deployable to servers. Let's get started by installing Docker Desktop. This is the Getting Started page. You would see Docker Desktop and you would see download for Windows, Mac, and Linux. Let's say we will download it for Windows, we will install it, and once installed, we will see this Docker icon running. If we go to settings, this is the general settings for Docker Desktop. It has when to start Docker Desktop, whether to automatically check for updates. And here you see which drives from my PC are shared to Docker. In the Advanced tab, we see how many CPUs are allocated to Docker, how much memory, 4 gigabytes, and how much swap storage is 1 gigabyte. And here how much disk space Docker is allowed to use. In this case, it's 59 gigabytes. Now let's go open a Windows terminal. And let's type Docker version. This command will make sure that Docker client and server are running. They're able to connect to each other. In this case, when I'm running it on Windows, the client is the command line Docker. This is the client. This is the version. It's Community Edition. And it communicates with the server. The server runs in a virtual machine. Because I'm running Windows and I want to run Linux containers, it creates a virtual machine, a Linux virtual machine, and it has the server. So this is the server running on the Linux virtual machine. It's the same version as the client. Other commands like Docker images will list all the images that I have downloaded. So as you can see, I downloaded lots of images. And then if I type Docker PS, it will show me the list of containers that are actually running right now. And as you see here, this list is empty. So I have all of these above images are downloaded, but none of them are started or running. So let's go to the next step, which is if I am a developer, I have my code base, an application, and I want to build a Docker container out of it, a Docker image. So first step, let's go see this folder, test one. This is an existing application. It's a new project, an ASP.NET project. I can open this project with VS Code. And let's pretend I don't have the dependencies needed to build this project. I don't have .NET SDK installed. I don't have Visual Studio installed. So I need to download an image, a Docker container that is able to build this type of project. And at the same time, I'll open a documentation page from Docker that explains how to Dockerize an ASP.NET Core application. And for the first step, it tells me to create a Docker file in your project folder. So I'll go here, I'll create a new file. I'll name the file Docker file. This is a standard name for any Docker file. It has to be Docker file without any extensions. And as you can see, VS Code identifies it's a Docker file and it uses a Docker icon for it. And then this is the standard commands that I would need. I'll just paste it in my Docker file here. And let's go over these commands and understand what it's doing. As you know from previous episode, to create a Docker image with my application, I need to download an existing image. It contains multiple layers, and I would keep adding layers to that image. With each layer contains an extra step of files, folders. So for the first command here, it says from Microsoft.com.net/SDK version 5. So this tells Docker download this image from Docker Hub with version 5. And you would see two commands that looks like that in this file, this one and this one. In this one, we are downloading ASP.NET image, and in this one, we're downloading the SDK. And the difference is the SDK has all the tools to build and compile and publish a project file, while the ASP.NET has only the web host version of the ASP.NET, where we can host an ASP.NET application. We can deploy this version to the production that doesn't necessarily have all the utilities that are needed to build a project. So we get the SDK version, and here we are telling it, call it build environment. We will download an image, we will call it the build environment. We'll get our code to that image, we'll build it, we'll create an output, and then we will take that output and move it to the ASP.NET container. So that we have two containers, one to build and one to host. So for the build environment, the one that we would use to build, the next step is create a work directory, call it /app. And then the next step is copy CS project file to this app. And note that here we're copying only the CS project file. The CS project file is only this file. It's not the whole project. It's just the project file that identifies that this is a .NET 5 project, and it needs these dependencies. These are the packages that are needed by this project. And why we're only copying this file? Because we want to run .NET Restore on that file. It will restore all the packages needed. And this will create a layer that we're able to cache. And this layer can be reused with different versions of our code. And then the next step, we will copy the rest of the files to this folder. So the rest of the files in this case would be called /. This will copy everything else. And then I'll call another command, run .NET publish. .NET publish command will compile my code, build my code, and create a published version with the release configuration, and we'll put it in the output folder called out. So there's a new folder will be created named out. This folder will contain the published version of my website. And then here we're saying using another version, another ASP.NET image. I'll change this version to 5.0 because our application is 5.0. Create a work dir called app, and then copy from the build environment container. From this folder inside of it, like take the app /out. So we're not taking the whole source code. Originally, we copied into the other container. We will only take the output that was generated from this step. And we'll copy it to this container in the dot folder. The dot folder is the current folder, which is /app. And then last command here is called entry point. Entry point tells Docker that whenever you start this container, this new ASP.NET container, run this command, run the .NET command and send it this DLL. And this DLL needs to be named test1, the name of my application DLL output. So now the next step is to build this Docker file. When I tell Docker to build this file, it will start executing all of these commands except the last one. And for every command of these, it will create a step and a layer. And these are on top of each other. So let's go to the next step. In this documentation, it tells me run docker build command. I'll go to my folder. I'll open a new command terminal. I'll paste this command. And this command tells Docker to build an image. The last dot represents the current folder, which is test1 folder, and tag this image ASP.NET app. So we will name the new image coming out of this build. It will be named ASP.NET app. Let's run this. And as you can see, it will start running 10 steps. And for each step, it's creating a layer with an ID. And for some layers, it coincides that similar layers existed in my machine. So it used that layer instead from cache, instead of creating a new layer. This happened for the CS project file. It happens for the .NET restore command. We're using cache for all of these, but for copying the code, it starts to create new layers because this code is different. And as you can see, the command successfully completes. And now I can go to the next command, which is to run this Docker image. Let's paste this one in, but let's read it first. It says Docker run. It says map port 8080 to port 80. Because my application is a web application, it opens port 80 inside the container. But because my machine could have other applications with the same port 80, I'm mapping 8080. And then I'll name the new container my app, and this my app container will use the image called ASP.NET app. Let's run this. It's executed. Now when I go to Docker PS, it will show me that there is a running container based on this image, based on this command. It's created 7 seconds ago, and it's up. And it has these ports mapping, 8080 to port 80. Let's open our browser. Let's type in localhost 8080/weather forecast. Weather forecast is the name of the controller of my API. And as you can see here, we're returning this result from my application. Now let's try to make an update to our application. Let me go to this weather forecast controller. I'll change this range to return 5 results instead of 3. Now I want to rebuild my container image. I want to restart my container. So first thing I will do is to say Docker stop my app container. And then Docker remove my app container. Now when I go to Docker PS, I see nothing. That's good. Now let's run the build command again. That's my build. Now let's run my container again. As you can see, it started. I can refresh this page, and I see now it returns 5 results as expected. Let's try one more thing. Let's type in Docker. Let's type the same Docker run command. I want to run another instance of this container, and I'll make it point to port 90. And I'll call it, I'll leave it my app. If I click enter, you will notice an error saying that this my app name is used by another container. So I'll call it my app 2. Another error tells me that you already named another container my app 2. Let's try to run Docker PS. As you can see, here there's only one container running, which is in port 8080, and it's named my app, not my app 2. Where is my app 2? I need to call PS command with a -a. This will get me all the both running and not running containers. And as you can see, this one is terminated. I have here two containers. One is called my app and my app 2. And this one is terminated because it couldn't open port 90. Let's say Docker remove my app 2. And then let's run my app 2 again with port 90. It starts. Let me go Docker ps dash without the dash a. It will show me that both of them are running right now. This is port 90, this is port 8080. And I can see here, I can refresh, port 8080 is still there. And I can access as well port 90, and it's opening the application as well. So here we see how to build a .NET application, how to containerize it, create an image out of it, run 2 instances of it at the same time using 2 different ports. Now let's go to the second part. As a developer, once I tested my application and it's ready to go, I ran it on my local machine. Now I want to ship my application. I want to package it. I want to give it to a system admin or a DevOps engineer where he can deploy it to any server or any other machine than mine. So the way to do this is by sending this packaged image to a registry, a container registry. Docker Hub is the default container registry. Let me go to Docker Hub. As you can see, I'm logged in with my account, and in my account, I have multiple images here. One of them is this ASP.NET app because I built it before. But in this case, we want to ship a new version of this image. So let's try to say Docker tag the my app, well, it's not my app, it's ASP.NET app image, tag it Bishoy / ASP.NET app, and give it a 3.0 version. This is like giving an existing image on my machine, giving it a new tag. This is only staying on my machine. But then the next command would be Docker push, and I'll give it the same image name with the full tag name. And as you can see, it's now uploading the layers that I have in my machine. Most of them already exist on Docker Hub. The same layers already exist. There's one new layer, which is about 5 megabytes of files that are being pushed online. As this process is completed, now I can open this registry on Docker Hub. It will show the versions, the different versions that I have, and I see here 3.1 is uploaded, and it's pushed a few seconds ago. So now this image is publicly available for another engineer to download from any machine. This is how I packaged my application. And as I create new versions of my application, I can keep uploading them here, and anyone can download any of these versions of my application. So as we saw in this episode, we were able to take a .NET application, create a Docker file, and build this Docker file to create an image, give a tag to this image with a version number, and push that tag to the Docker Hub. I hope this episode is beneficial to everyone. Thanks for watching. Please like and subscribe and share. Thank you very much.